हेलो। मैं शोभन हूँ और मैं आज आपको ट्रिगोनोमेट्री पढ़ाऊँगा। ठीक है। तो ट्रिगोनोमेट्री इज बेसिकली द मेजर ऑफ एंगल्स एंड द साइड्स ऑफ अ ट्रायंगल एंड द कंपैरिजन बिटवीन देम. It comes from three words in Greek: tri, gon and metron. Tri means three. गॉन का मतलब है साइड्स, मेट्रॉन का मतलब है मेजर, which implies the fact that it tests the different sides and measures and the angles and the comparison between them. Okay. ट्रिगोनोमेट्री में मेन चीज जो होता है वो होता है साइन, कॉस, टैन और उनके इन्वर्सेस. These are basically the angles. I'll be defining them right now. Let's suppose a right angle triangle ABC with right angle at B. ठीक है. ABC. Now the meaning of sine is let's first define the sides. This AC is called the hypotenuse, and for now let's call BC the side opposite to angle A, and let's call AB the side adjacent to angle A. ठीक है. Now the thing is sine A. Sine A is defined as the side opposite to angle A divided by the hypotenuse, which is basically nothing but the side opposite to angle A is BC and the side hypotenuse is AC. Okay. Similarly, cosine A is defined at the side adjacent to angle A divided by the hypotenuse, which is nothing but AB divided by AC. Right. Now the other ratios. Tan A. Tan is tangent of A. This is the side opposite to angle A divided by side adjacent to angle A, which is nothing but BC upon AB. Alright. Now we come to the inverse ratios. What are the inverse ratios? The three remaining ratios that are cosecant, secant and cotangent. I will be defining them. This is still a right angle triangle, so let's start with cosecant. Cosecant is the inverse of sine. Cosecant of A is equal to sine A inverse, which is 1 by sine A, which is sine A was side opposite to angle A, means BC, divided by hypotenuse, which is AC. Cosecant is opposite, means hypotenuse is in the numerator and side opposite to angle A is in the denominator. So this is AC divided by BC. Similarly, secant A is the inverse of cosine, and it cos A was side adjacent to A by hypotenuse, so its inverse becomes hypotenuse by side adjacent to cos A. This is AC by AB. And the last ratio left is cotangent. Cotangent is the inverse of tan. Cotangent of A, this is equals to tan A to the power minus 1 by tan A. Tan A was side opposite divided by side adjacent. Cotangent is just opposite, so it will be side adjacent by side opposite. This will be AB by BC. Okay. Now, since we don't use the full forms all the time, we use short forms. Like for sine, we don't write SINE, we write sine. And for cosine, we don't write cosine whole but cos. So the angles, the ratios become sine A, cos A, tan A, and their inverses. Sine A's inverse was cosecant, so in short we write it as cosec A. Cos inverse was secant, so we write it as sec A, and tan inverse was cotangent, so we write it as cot A. Okay. There's an interesting thing to note about tan A and cot A is they can also be measured in terms of sine cos or cosec and sec. How? Let's see. See, tan A, this was equal to opposite by adjacent. So this will be BC upon AB. Now if we divide both numerator and denominator by the hypotenuse, that is AC. So this becomes BC by AC whole divided by AB upon AC. This equals, what was BC upon AC equals? Sine A. So this equals sine A by cos A. Similarly for cot A equals side adjacent by opposite AB by BC, and dividing both numerator and denominator by the hypotenuse, we get this as cos by sine, which was obvious kind of, because it is cot A is the inverse of tan A, and since tan A is sine by cos, cot A becomes cos by sine. Now the thing is, we can also interpret this as cos A, I mean in the denominator it is, in the numerator it is 1 by sine A, and in the denominator it is 1 by cos A. So this becomes cosec divided by sec. Alright, now these ratios are very important, and it is very important that you learn all this, so please take care that you do not skip any of these or take it lightly. Okay, now let's move on. We still have a right angle triangle. Now the thing to note is that this is angle A, this is angle C. The ratios define the ratios of the sides. The trigonometric ratios define the ratios between the sides, but as long as the angle is constant, we can extend the triangle to any dimensions, but the trigonometric ratio won't change even though the length of the sides change. This is property of similar triangles, because when angle A is constant, even if we extend AB and AC accordingly and BC, since angle A is constant, BC upon AB and all the other ratios will remain same, so the trigonometric ratios also remain the same. Okay, let us do some examples to help you understand. These are mainly the NCERT examples, so if you have any problem in understanding, you can always refer the book also.